Okay, so here we're going to take a look at graphing parametric equations. So we're going to use Desmos to kind of help us graph these equations, right? Now remember, when given parametric equations, so we want the graph, but the graph also has a direction to it. Okay, so it's not enough to write the curve. We have to show those arrows to give us the direction or the path of the curve. All right, now here the previous video we went over how to plot points, graphing it that way. But here let's take a different approach. We're going to use Desmos. And the way we plot Desmos, we're going to plot it like an ordered pair, where the first coordinate is my x coordinate, but it has the parameter t. All right, and the second one is the y parametric equation with the parameter t. So Desmos recognizes this as being a set of parametric equations, and it generates the graph that we see here. Right? You can mess with the parameter of t. Now in this case, we said t is greater than 0, so we can actually put 0 here. Right? And actually, I don't think it really, I think here, in this case, we can let t be any real number here. So actually, I didn't want it to be bigger. Let me adjust the domain, right? So t, we go from t be any real number. Okay. All right. And here, so forgot this one too. This one, I want t to go from 0 to pi. All right. Okay, so here you can adjust, obviously it doesn't take infinity, but we can play around with just numbers, let's say negative 50 to 50 here. So it looks like we got half of a parabola here. Right now, if you want to see, all right, well, what is the orientation? Desmos doesn't directly give it to you, but you can play around with the parameter. Let's say we go from 0. Right, and so from negative 50 to 0, we get that portion of the graph. And as t increases, let's say 6, all right, so you can see kind of as t increases where the graph goes. So that kind of, that gives me the orientation, right? It does something like this, where it goes in this direction here. And as t increases, the graph heads out in that direction. All right, and you can determine that just from playing around with the parameter to see kind of as you increase t or decrease. But I usually tend to just start with a smaller value of t and then increase the value and see in which direction the graph goes, and that tells you the path of the curve. All right, so now let's take a look at the next one here. All right, so here we have t and 25 minus t squared. Okay, and we see that's about a quarter of the circle there. Now again, this doesn't tell me the orientation, but again, let me change from 1. So notice here at 0, it starts up at 5, and then notice in here 2, 3, 4, 5. Right, so you see the orientation of it, right? So we have a quarter circle here. And we see from the graph the orientation. Okay, and now the last one here. So negative 2 cosine of 16. Right, so it looks like an ellipse, right? So now let's figure out here. Looking at the graph here, so I'll turn this one off. So negative 2 cosine t. So we get half an ellipse. And now let's look at, again, what's the orientation? So let's see, pi over 4, right? So it looks like at 0, it starts over here at negative 2. And then as it makes its way to pi over 2, we're up at 6. And then lastly, at pi, we get back to 2, right? So it's half an ellipse, the half that is above the x-axis, right? Where this is negative 2, 2, 6, so it does something like this. And then from playing with the parameter, we saw that it is oriented in this direction here. Okay. All right, and here for curves that are more complicated, and these aren't so complicated, but just in general, right, we have technology that'll help us to figure out what the shape of these graphs look like.